Hey guys, and welcome back to another video on the channel. In today's video, we're going to be looking at the Math Methods Paper 1 Tech-Free multiple choice booklet for the Sample 2020 assessment. So this isn't an actual paper that was released to the curriculum. It's kind of like this is a paper of kind of what you're getting in 2020. So they released this before the actual external exam just to give the students an idea of what type of layout and pretty much types of questions you're going to be getting. But regardless, it's still a pretty good test to practice, and let's just get straight into it. So this is a calc-free one, but yeah, let's get straight into it. So this is for the QCAA syllabus for Queensland. Alright, question 1. A random variable x is binomially distributed with 10 trials. The probability of success equal to a quarter at each attempt. The value that the probability of x is greater than or equal to 1 is equal to which of the following? Okay, so binomial probability, there's some tricks you need to know. So the probability that something is greater than or equal to 1 is the same as 1 minus the probability that it's equal to 0. Because if it's greater than or equal to 1, then it cannot be equal. It cannot be the probability that is equal to 0. So the complement of that is, alright, if it's a probability, the probability that it is equal to 0 minus 1 gives you that probability. So we're going to be using this fact pretty much to answer our question here. So I'm just going to move this out the side, and pretty much we need to unpack what we have in this question here. So for example, it's a binomial probability, so I know n is 10 because it's 10 trials. Probability of success is 0.25. So we need to work out the probability that x is equal to 0. So in other words, using our little formula here, so the formula for binomial probability is n choose r times by the probability of success to the power of r times by 1 minus the probability of success to the power of n minus r. So in this case here, n is 10, so we have 10 choose 0, because we're going to be working out the probability that x is equal to 0. So 10 choose 0 times by 0.25 to the power of 0 times by 1 minus 0.25 is 0.75, and up here will just be 10. So that all cancels out because 10 choose nothing is 1, and 0.25 to the power of 0 is 1. So the probability that x is equal to 0 is 0.75 to the power of 10. So the probability that x is greater than or equal to 1 is 1 minus this probability, so 0.75 to the power of 10. Now 0.75 is the same as 3/4. So the correct answer is D, because it's got 1 minus 0.75 to the power of 10. They've just written it as a fraction. Okay? If you have any questions about this one here, leave something in the comments. Now, if it's about any questions, just leave something in the comments and I'll try my best to answer it. But that's how you answer question 1 for this particular sample. Right, so I'm just going to rub this stuff out just in case I need a bit of room for this next question. Okay. So question 2. The approximate area under the curve y equals 2x squared between x equals 1 and x equals 4 can be found using rectangles. Width equal to 1 unit, as shown in the diagram. Okay, so we're approximating the area by pretty much finding the area of these rectangles and adding them up. So this is pretty easy because their widths are just 1. So 1, 1, 1. They all have a width of 1. We just need to find their heights. Now their heights are going to be the corresponding x values that you plug into this equation here. So for example, the y values when x equals 2, the y value when x equals 3, and the y value when x equals 4. And that will be the heights of our rectangles. So the first rectangle still got a width of 1, and it's got this length here. So we'll be finding that. So it's going to be, alright, y equals 2x squared when x is equal to 2. So you're going to get y equals 2 times 2 all squared. So y equals 2 squared is 4 times by 2 is 8. So the height there is 8. And that is the first rectangle there. So rectangle 1. Righto. So now we're going to do the same thing for the other 2 rectangles. So now we need the height when x equals 3. So we get y equals 2 times 3 squared. So y equals 2 times y. So 3 squared is 9. So 2 times by 9 is 18, so the height is 18. So we have the next rectangle, so 1 and 18, and that is the corresponding height here. Right, let's do the final one, so let's just rub this stuff out. So when x is equal to 4 now, y equals 2 times 4 all squared. 4 squared is 16, times by 2 is 32. So the final rectangle is going to have a height of 32. Okay. So what that pretty much means is we need to find the pretty much area of these rectangles here. So the way we do that is just length times width, pretty much. Pretty basic stuff there. Oh, what I do? I turned on. There we go. So because they all have a width of 1, 1 times 8 is just 8, 1 times 18 is just 18, and then 1 times 32 is just 32. Add those two numbers together, you're going to get 50, plus 8 is 58. So the approximate area is 58 units, so the correct answer is A. And that's who would answer question 2. Let's move on to the next question. So question 3. Y equals cos squared, brackets 3x, find dy dx. Okay, so this is going to be an application of chain rule. So y equals cos squared of 3x is the same as writing it like this. It's just a shorthand by putting the squared right where the s is, but they mean the exact same thing. So what we have is kind of like well, my math teacher called it a turducken. So it's pretty much a function inside a function inside a function. So when we do chain rule, we need to differentiate the outside, then the middle bit, and then the final bit. So when we apply the chain rule, we've got to differentiate the outside function first. So the outside function is pretty much this squared power here. So when we differentiate that, we use the power rule, bring that power down the front. So we get 2 minus the power, and just leave the rest of this. Okay. So that's our first bit done. Now it's going to get multiplied by the differential of this bit here. So if I differentiate cos, it turns into minus sign. But notice we also have a function in here. So we need to multiply by the differential of that. So we're going to have minus sine of 3x, and then times by differential 3x is just 3. So what we're going to get is, alright, dy dx, I'm just going to write down here, is minus 6 cos 3x sine 3x. And we can see from our working here, there's only one correct answer, and that is A. And that's who would answer that question there. Okay. Let's move on to question 4 now. So, if the integral from -2 to 0 of f of x dx is equal to 4, and the integral from 0 to x equals 3 of f of x is minus 10, which of the following is true? Okay, so when looking at this question, we can see they're all wanting the integral between -2 and 3. Now, notice they haven't mentioned area, okay? So, the area and the integral are two different things. So, for example, if we had a curve like this, and I wanted the integral between, let's say, here and here, so those are your bounds, that would give me a negative number, and that would cancel out with some of that, and that would give me an overall different number than the area, because the area, you pretty much turn the entire negative bit positive. So they haven't mentioned the word area, so we're only looking for the integral, okay? So what we have here is a bit of a weird situation. So what we're going to do is draw an axis and try and predict kind of what we have. So we don't know what f of x looks like, but we know between -2 and 0, it has a positive area. So we can assume it looks something like that, okay? So that whole area there is positive 4, okay? Now, I'm just going to finish off our curve, and between 0 and let's extend my axes real quick, 0 and 3, we get -10. So let's say this is this is positive 3, we get -10 here. Now, if it's the area is going to be 14. So that's why they've got this answer and this answer here. But that's not correct, because they're asking for the integral. So the -10 and the positive 4 are going to cancel a bit of each other out. So it's just going to be -10 plus 4. So the answer is -6. And the correct answer, yep, is B. And that's how you would answer that question there. So it's a bit tricky, that one. But you've got to look for specific wording. So if they don't mention area, you just assume it's an integral, okay? Which is a different thing, okay? Oh, I didn't need to rub that out, but anyway. Right, so let's go down to question 5. So the slope of the tangent to the graph y equals natural log of x squared at x equals e squared is. Okay, so first of all, we need to differentiate our function here. So I'm looking at this guy and I'm thinking chain rule because I have an inside function which is my x squared term here. Okay, so differentiating the outside, if I differentiate natural log, it's going to be 1 over that function, so x squared. Multiply by the differential of an inside function, bring that 2 down the front, subtract that 2 by 1, you're going to get 2x, okay? So we get dy dx is 2x on x squared, and I can cancel one of the x's, so I get 2 on x, okay? So that is my function for dy dx. I'm just going to write that there. Dy dx is 2 on x, okay? Now, what they're asking for, they're not asking for the equation of the tangent, because notice they are just asking for the slope. So the slope means the gradient. So they want the gradient at x is equal to e squared. Now, this is just a number, okay? Now, this function here will tell you the gradient at different x values. So all you got to do is plug in this x value into this equation here. So in other words, the slope is when dy dx is when x is equal to e squared is equal to 2 on e squared. And we can see the correct answer is B. And that one's done. If you have any questions about this one here, try and leave something in the comments and I'll try my best to answer them. But let's move on to the next question. Alright, so 6. Calculate the integral from -1 to 7. Okay, so if they have the word calculate and there's no area, it's just an integral. But yeah, let's just get straight into it. So what we're going to do is just write it like this for now, but we're going to start changing how it looks. So if it has a dx there, you can actually just write it as 1 over the square root of all this rubbish here, and just move the dx to the side, because the dx is just being multiplied anyway. Now, the square root of something is the same as that something to the power of a half. And if you have 1 over something, that something can be written as that something to the power of -1. So we can flip the exponent pretty much. So we're pretty much going to do both of these ideas in one. So we're going to change how this looks straight away. I have a square root, so I can change it to the power of a half, and it's 1 over, so I can change it to a negative exponent. So I can change this integral from -1 to 7, all this rubbish in here, 2 plus x to the power of -1/2 dx. Okay. Now what we're going to do is a u substitution. So we're going to change our variables real quick. So what we're going to do is look for the biggest inside function. So the biggest inside function I can see is here, okay? So I'm going to let u equal 2 plus x, okay? Now when I'm changing my variables, I need to change my differential as well. So in other words, I need a du. So the way I find a du is just differentiate both sides. So I get du on dx equals, and this side just turns to 1. So if I move the dx up there, I get du is equal to dx. So when I change variables, there's no factor that's really changing. Now, I also need to change my bounds because this is when x is equal to 7 and x is equal to -1. So, when x is equal to 7, I put the 7 in here, and then u is equal to 9. So I'm just changing my bounds by plugging it into this equation here. So I plug 7 in there, I get u is 9. Right. So if I plug in then, when, x equals -1, I get u is equal to 1, okay? So in other words, my integral changes now to 1, 9, I replace it with u to the power of -1/2, and the dx would just du, and that's done. So what I've done is I made the integral very easy to integrate now. So I'm just going to rub this stuff out because I've run out of room. So we have, let's change the color back to black. 1 to 9 of u to the power of -1/2 du. Okay, and we don't need to change back because we changed our bounds as well. Okay, so let's just rub this stuff out. We can do an ordinary power rule. So when we're integrating, we add 1 to the power. So it'd be -1/2 plus 1 divided by that. So -1/2 plus 1 divided by. And the square brackets, 1 and 9. Now, -1/2 plus 1 is just +1/2, so what we're going to get is u to the power of 1/2. Negative 1 plus 1 is a half, but it's being 1 over, so it's going to be the same as times by 2. So we get 1 and 9. So rub this stuff out now. Substituting in the 9, we're going to get 2, 9 to the power of a half. Substituting in the 1, minus 2, 1 to the power of a half. So a half is just a square root, so 2 times the square root of 9 is 2 times by 3, so that's 6. And here we just have minus 2 because the square root of 1 is just 1, so the answer is 4. And the correct answer is D. And that's how you solve question 6. Okay? So a bit of a stretch this one, so some multiple choice questions are longer than others, but with enough practice and preparedness, that's not a word, with enough preparation, you should be able to do this fairly quickly. The only reason I'm taking my time with this is because I'm explaining it step by step. But let's go down to question 7. So, question 7. The the distribution of marks shown in 3 subjects are given below. The mark received by a student in each of the subjects is also shown. Okay, so standardized Z-scores were used to compare the results and show that the student... Alright, so we're assuming it's a normal distribution, so Z-score is equal to the data point, X, minus the mean, divided by the standard deviation. So let's work it out for each of the subjects. So for science, student mark is 70. My mean is 60, and my standard deviation is 15. So in other words, I'm going to have 10 over 15 for science. That is my Z-score. So I'm just going to write that there. So Z-score is 10 on 15. Now I'm going to work it out for math. I'm not going to write mathematics, that's too long. So math. Your data point is 72. Your mean is 68, and your standard deviation is 6. Okay, so 72 minus 68 is going to be 4, and then 6. So the Z-score is 4 on 6. Right, and then we're going to do the 1 for music. Rub that out. So music. So our student score is 72. My mean is 65, and my standard deviation is 9. So what I'm going to get on the top is, what's that? 7, and that's 9. Okay, so now we can compare all the Z-scores. So whoever's got the biggest Z-score did the best relatively. Okay, so the Z-score, 7 over 9. We have the Z-score. This can be simplified to 2 on 3. And so can this one, 2 on 3. So that means math and science are the same, and music is the highest. Okay, so now we just got to look at the answers, because what they're asking for is pretty much, alright, which one of these isn't true? So, performed equally well in math and science. Okay, that's correct. Performed equally well in math and music. That's incorrect. Performed better in math than science. That's incorrect. Performed better in math than music. That's also incorrect. So the correct answer is A, because music has the highest Z-score and math and science are equal. So that is the only statement there out of these ones that is true. Okay. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it. Righto, so 8. Given y equals 5e to the 2x, rearrange to make x a subject. Okay, so just a bit of algebra, honestly. No fancy stuff. So try and get x by itself, divide both sides by 5. Now rewrite as a log, so natural log of y on 5 to cancel out that e. Then divide by 2, so we get x is equal to a half natural log of y to the 5. Since we have this number here, we can bring it inside the log to the exponents. So we have x is equal to natural log y over 5 to the power of a half. So if I distributed that, it'd be the square root to each of them. So we can see, okay, that's incorrect, that's incorrect, that's incorrect, that is the only one that's correct. Ta-da! Alright. Question 9. An equilateral triangle side length 9 meters. Calculate the area of this triangle. Okay, so you're going to be using this formula from trigonometry. Half AB sine of A. I think that's it. Actually, I'll double check. Let's go to the formula sheet real quick. Where's trigonometry? Ah, there it is. Okay, my bad. It was meant to be C. Oh well, same thing. CB. So this formula works when you have this scenario pretty much. You have this angle here A, and you have the side lengths C and lowercase b. Okay. So we have an equilateral triangle. So all the lengths are the same and all the angles are the same. So the sums of an angle in a triangle need to add up to 180. If they all have the same angle and there's 3 vertices, you just divide 180 by 3. So you get 60 degrees. So we have 9, 9, 9, 60, 60, 60. Okay? So using our formula here, so area equals a half CB sine of A. My angle is 60 degrees. Now, you can work out sine of 60 degrees without a calculator if you remembered your special triangles. So the special triangle, your 30-60 triangle. So 60 degrees, root 3, 30 degrees, 1, and 2. Okay? So sine is opposite on hypotenuse. So opposite hypotenuse. So sine of 60 is the square root of 3 on 2. Okay? C and B are both 9, so you're going to have area is a half times by 81 times by root 3 on 2. So you're going to have 81 root 3 on 4 as your answer. So the correct answer is C. Ta-da! Righto, so that one took a bit of thinking and you need to remember some stuff with that particular question, but it isn't too hard relatively. But yeah, that's why you need to remember your special triangles, because that won't just pop up in examples with the trig, it'll pop up in examples with integration when you have to use the trig. Okay, so question 10. If the sample sizes decrease, but the sample proportion and the confidence level remain the same, the width of the confidence interval A increases, B decreases, remains the same, D may increase or decrease. Okay, so a confidence interval relies on pretty much this. It's a width from your proportion. Okay, so we're looking at this formula here. Now n is decreasing. Now if n is decreasing, that means this, hold on, you can use red. This whole number, it's the width of the interval. It's increasing. So the width is increasing because this number is getting smaller. And if you have, let's say, 100 over 2 compared to 100 over 50, the bigger number on the denominator is the smaller one. So if this number is very, very small, then the whole number itself is just very, very large. So that means the width of the interval is increasing. So the correct answer is A. Ta-da! And that's how to answer that one there. Right, so that was the, what was it? Math Methods, Paper 1, Sample Assessment for 2020 done. If you have any questions about anything I covered today, leave something in the comments and I'll try my best to answer them. But I'll see you in the next video.